example, okay? The terminal arm of angle theta in standard position passes through point A, and the point is at 1, 4, okay? Determine the length of OA, that's just the name of the line, to 2 decimal places, okay? To 2 decimal places. So, what we're going to do is I know here that based on this, I can drop this here. Sorry, that should be straight, but that's a 90-degree angle. Everyone agree with that? I know based on this information, the base is... Sorry, that really does not look straight. Let me fix it. Is that better? Okay, so the base is 1, because that's my x value. Remember, these are always x, y. My height is 4. And I do not know my radius. Does everyone agree with that? I don't know my radius. But it's not a big deal. I have a right angle triangle. So we know, and it's over there, we know c squared equals a squared plus b squared. But are we using c, a, and b anymore? No, we're using r, x, and y. So it's going to be r squared equals x squared plus y squared. Okay, well that's perfect. I have x, I have y, so I can solve for it. So I'm just going to come up here due to lack of the space. R squared is equal to 1 squared plus 4 squared, which equals 16. I'm going to take the square root of both sides. Therefore, R is equal to 4. Okay, so this is just Pythagorean theorem. It's just Pythagorean theorem. We're just using x, y, and r instead of c, b, and a, b, and c.
I got 17.
Oh, I'm sorry. Yes, I didn't do an addition. That's my fault. Thank you. I didn't add the ones. Can you tell me the square root of 17? Because it's going to be decimal.
No, it's not. Oh. 4 decimal 1, 2, 3, 1.
So I don't know. I'm going to take it to 1 full unit because that's what the other side lengths are. Oh, no, I'm not actually. Because otherwise it's going to look like the same side. So I'm going to take the 2 decimal places. Otherwise it looks like it's the same height as the triangle, which it is. Okay, now what it's saying is we have x, we have y, we have r. They just want us to set up our trig ratios. So we know they're over there. And we also know, because we just learned them, that our trig ratios using a Cartesian plane is yr, sine is yr, y over r, cos theta equals x over r, and tan of theta is equal to y over x. Everyone agree?
Yeah.
So now we just plug in our values. So sine of theta is equal to 4 over 4.12. Cos of theta is equal to 1 over 4.112. So we're going to take that. And tan of theta is equal to 4 over 1 equals 4.
Yeah.
Okay. So it's really not that tricky.
It's just different.
It's different. It's different. It's new. You won't have seen it before, right?
Yeah.
I wasn't even taught this in high school.
Well, did you take this course though?
Yeah.
Oh. Okay. Oh, I need to recalibrate my board. Okay, so now this is the all-encompassing question. Hey guys, one. Hey, stop pressing.
Sorry, we're just saying the math department at St. Stephen's.
Hey, I don't want to hear about it. They're not here to defend themselves.
Well,
Okay,
I did it while
stop.
we were there to
No,
we're
recording. Stop.
Oh,
The terminal arm of an angle theta in standard position passes through the point. Stop, gentlemen. Okay, what they're saying is it passes through the point negative 5, 3. So they want you to sketch a diagram. All you do to sketch a diagram is draw a Cartesian plane. You know that this is x, y, negative x, and negative y. Okay? I'm showing you right away what I want to see in these diagrams for you to get full marks. Okay? Now, you don't have to get a ruler out. It's a sketch, okay? I just want it to represent what it is. Remember, in an ordered pair, it's always x, y, okay? My hands. It's always x, y. So in this case, your x is -5. So I come over to approximately -5. And my y is +3. So I'm +3. So that means my point is approximately there. Remember, it's battleship over 5 up 3. Right? Battleship over 5 up 3. So I draw my terminal arm. From my terminal arm, I draw to create my right angle triangle. I know my x is -5. I know my y is +3. Do I know r?
No.
Can I calculate r?
Yes.
Okay. And they call this x and then the origin, right? So r squared is equal to x squared plus y squared. So r squared is equal to -5 squared. Use the bracket to enclose the negative, otherwise you will get an error or the wrong answer. Okay.
Robin's home on my Wednesdays, Robin.
To do that. Okay, now all it's asking me to do is set up my trig ratios. I have x, I have y, I have r. That's it. Okay? Sound good? Now, I just want to draw attention to one thing, okay? One thing. Can everyone just look up? When I set up my trig ratios, for example, like sine of theta is equal to y over r, so sine of theta is equal to, what was y? Y is 3 over 5.8. No, wait. Everyone just look up for a second. Look up for a sec. I promise you will want to see what I'm actually doing here for when you do your homework. Okay, does everyone agree that theta is actually this angle here?
Here.
Right, it's that angle. However, the question is actually asking for this angle. Because it wants to know from where it starts to where it rotates what the angle is. So if it ever asks, this question isn't asking it, but if it ever asked, what is the angle of the rotation of the terminal arm, this is when you would have to do the, okay, well, let's say we're going to label this beta, even though I'm sorry I know you hate it. Angle beta is equal to, this is when you have to say, well, 180 degrees is that full rotation. Then I'm going to subtract what I calculated for theta. Okay? So what I'm saying now is I'm taking us back to what I wrote here. Okay? Because, again, the angle you're finding is just the angle of that right angle triangle. It is not the angle of that entire rotation. Okay? So just keep that in mind. If you get stuck on it, absolutely I'll help you. It's not a big deal. Okay, so now you're just going to finish writing down the other trig ratios. So cos is x, so -5 over 5.83, and tan theta is y, so 3 over x, so -5. Now, if you look at the cast rule, this is a prime example of cast, right? Cast is at C-A-S-T. What quadrant are we in? What quadrant is this terminal arm in? The second. The second tells us only sign's going to be positive, right? Only sign in our answer was positive. Positive, negative, negative. Okay, so that's how the cast rule works. Is that good? Yes?
Wait. Yeah.
Did someone say wait? No? Oh, okay. Let me just see what I have here, and then I promise. Okay, this one is easy. All you do is think about the angle itself, and let's just do this really, really quickly, okay? Really, really quickly, and then I'll let you go for break. Based on cast, all this is asking is if it's positive or negative, okay? So 28, all of them are in the first quadrant with 28, right? So they're all going to be positive. 140 will be in this quadrant, right? So what's the only one that would be positive? Sine. So sine will be positive, the others will be negative. Okay, 58 again is in this first. It's between 0 and 90. And remember, this is 0, 90, 180, 270, and back up to 360. Okay? So this again will be in that first quadrant, so they're all positive. And 104, which quadrant is it in? Sine. I don't know why the answers here are the same, but like if it was here, what would only be positive?
Cosine.
If it was here, what would only be positive? Here, tan. Okay? Okay, we'll do this when we get back.
Period 1 is over.
Okay, so now this one's a little different, okay? Because it's giving you different information. It's saying the tangent of an acute angle in standard position is 4/3, okay? So we know tangent to be what? What letters is it? The actual ratio. It is y over x. I don't know why it writes like that. Sorry. This is y over x. Does everyone agree with that? So therefore, without having a diagram or anything, we know what our values are, okay? It's saying acute, meaning so it's a less than 90-degree angle, so it's going to be in quadrant 1, okay? It's going to fall in quadrant 1. So it's now asking us to sketch it. So what I'm doing is I'm going, okay, well, it's up 4, it's over 3, so my terminal arm is approximately there, and that's my right angle triangle. Everyone agree with that? So again, all I did was I got those values because I know that tan is y over x. So if the number is 4/3, I know my x is 4, or my y is 4, excuse me, and my x is 3. So that's how I'm getting those numbers. So let me just see. The tangent here. Oh, so sorry, this we already did. I'm like overthinking this. The coordinates are 4 as 3 and y. Sorry, x is 3 and I can't talk today. And y is 4, and we're just getting those from that point. Okay. I was reading that question. It's like they gave us way too much room here or something. Right? So all it's saying is what is a point on the line? Well, I know a point on the line is 3, 4 because I get that x and y value from the tan ratio. Now, it's asking me to set up sine and cosine, but I actually need my r first, okay? Before I can do that, I need to calculate r. So r squared is equal to 3 squared plus 4 squared. R squared is equal to 25 squared. So I'm taking the square root. So R equals 5. So based on that information, I now have x, y, and r. I can just sub in for sine and cosine. So sine of theta is equal to y over r. So sine of theta is equal to 4 over 5. And cos of theta is equal to x over r. So cos of theta is equal to x is 3 over 5. Okay, now the good part about this is because we're in the first quadrant, they're asking for theta, and theta is just whatever the number is here because we're calculating. So what I'm going to do is I'm going to use sine just because. You could use cosine, you could use tangent, it doesn't matter. I'm going to say, okay, well sine is 4 over 5, so I'm going to 4 over 5 equals 0.8. So I need to do this, remember -1, 0.8. And that'll give me my angle. So I'm going to hit second function, sine, 0.8. I'm going to hope that mine's in degrees, which it isn't. So I'm going to go and change my calculator to degrees. And I'm going to do it again. Second function, sine, 0.8. And I get 53 degrees. Angle theta equals 53 degrees.